And happy Sunday. This is PFG Live. Hi, everyone. It is a kind of rainy, but otherwise beautiful fall day here in New Hampshire. And we have a lot of people checking in. Tuck was here. He had a run, but he said the weather is Buffalo. Carl is here from Rhode Island. He says it's 76 and sunny in the People's Republic of Rhode Island, even though it's about 50 degrees and raining. Who else is here? We've got DBX is checking in with the METAR from White Plains, where he reports the winds are 080 at 9 knots, visibility 1.5 statute miles in light rain and mist. Clouds are broken at 700, overcast 2,000, temperature 11, dew point 09, altimeter 3010. Well, welcome. Who else is here? Unix Carbide reports from Williamsburg, Brooklyn, New York, 55 degrees, 75 degrees, 79% relative humidity, 6.06% relative humidity in the filament chamber. Outstanding. Evils is here from Belgium. And Evils reports 19 degrees science, 60% indoors in Ghent, Belgium. Been rainy all week. And Pat, I recognize you're there. Hit the button that says invite to speak and stand by. Let's see, who else is here? CJ Stevens is here, 76 and cloudy in East Tennessee. Welcome aboard, sir. Test Room 2003 from Oostkapelle, the Netherlands. Rainy, 11 degrees science, and at least 80% relative humidity. Rob Renz is here. All rise. Be seated. Rob Renz reports wet. Can't argue with that. Widgetworks is here. He says it's -2°C, 66% relative humidity in the frozen white north of Alberta, Canada. Welcome, sir. Let's see. Who else is checking in? Oh, there's Pat. Okay, Pat. We got you. And I'm going to... so we have an interview coming up today. And I am just getting that ready for you guys so that you're not confused. Okay, so we have a lot going on this week. It was a week full of distractions. So, as you could tell from the thumbnail, we have a couple of topics today. One is so-called Trebuchet Week, where I've been helping my son Jared design and build with his teammates a trebuchet for an event we call Treb Day, and that's coming up real soon. So let's get right to that. I'm going to turn on Discord audio, and I'm going to welcome aboard Mr. Pat Kaplow. Can you hear me?
I can hear you. Can you hear me?
Yes, we do hear you. A small delay, which is to be expected, considering that we are hundreds of thousands of light years apart. Pat is the physics teacher at the Windham High School, where he has been for, 15 years?
Almost. Yeah, 2010 was my first year there, so I'm on my way. And we did our annual Trebuchet Day in the second year, so we are doing our 12th this time.
That's just awesome. I have some pictures here of what the trebuchet looks like. Let's see if I can grab one that isn't a video. Which students participate in Trebuchet Day?
So we have all physics students participate in Treb Day, regardless of which level they're taking physics. I think you have a pretty international audience, so our highest level of physics we call advanced placement, or AP for short. If there are some folks familiar with the British system, it might be kind of equivalent to the A levels. And students who kind of perform high enough above a certain threshold qualifying exam at the end of the year will receive some college credit for that physics class, and then we have what we would call a standard level or college prep physics, and the conceptual physics as well.
Awesome. Uh, did you invent Treb Day? Was that your invention?
Absolutely not. The idea of building a trebuchet in a physics class has been done for eons, since the trebuchets themselves. I imagine medieval physics classes with trebuchets. They say that without gunpowder, the trebuchet was displaced on battlefields by the advent of gunpowder by the time it had reached Europe in the kind of, I think, 14th or 15th century would have been the kind of the end of the trebuchet. And I think that modern physics classes in the last 50 years or longer have been building trebuchets as a way to look at different aspects of the physics curriculum, most notably um, conservation of mechanical energy, right? You have a big counterweight that falls and converts some of that gravitational potential energy into kinetic energy of the balloon and rotational kinetic energy of the throwing arm, if you kind of are familiar with the operation of a trebuchet. But there's also kind of a analysis that can be done and some dynamics from plenty of rotational mechanics, moments of inertia with the design of the throwing arm, all the way to the trajectory and kind of kinematics of the projectile. We use a water balloon to kind of limit uh, kind of risks to our students and their teacher who's on the receiving end of that projectile. So, yeah, I think there's a lot of different ways to do this, but as in all things education, and I think in engineering as well, the devil's in the details, the devil's in the implementation. And our Trebuchet Day is kind of takes on this real festival atmosphere with kind of a bit of a tailgating feel to it, and community members who like to go and watch the events. And it's just kind of a big festival of nerddom, if you will.
Well, our audience consists of uh, machinists and engineers and nerds of all kinds. So I'm sure everybody truly appreciates it. What are the rules that you set out for the Treb Day?
So there are some small rules, but the big ones I think your listeners will be most interested in are the length of the throwing arm is 1.75 meters or less, because the rest of the trebuchet is scaled from that 1.75 meters, and therefore we don't need to put additional constraints because of that scaling. And then they are launching at a target that's basically a castle, a plywood dodecahedron, made out of half-inch plywood. That's the center of the castle is 35 meters away, or about 115 meters for your North American listeners.
115 feet. You said meters twice, but that's okay.
Oh, I apologize. Thank you. 115 feet, and the only reason that I know that is because I painted the field yesterday using an American with imperial units on it. So I had to do the conversions. Thank God for Siri. I would have been dead in the water.
We in the ante room here before we started the show. We're having a discussion about metric versus imperial, et cetera, et cetera. That's a constant theme. Pretty cool. And how many students, how many teams are I guess I should say it differently. How many trebuchets will be on the field?
So this year there will be 55 trebuchets. Are typically 3 students on a team. Sometimes there are 2. We don't allow students to work by themselves for a variety of reasons. But there are also students that are permitted to work by themselves on a mini treb, which is a 5-to-1 scaled model of what we would call our full-size trebs, capped at 1.75 meter throwing arm. So divide every number by 5, including the field, and we have a 5-to-1 kind of scale. And the smaller trebuchets can be built out of a variety of materials, usually, kind of typically wood, but also PVC is strong enough. Half inch
Hmm.
PVC is strong enough to form some of those materials on that kind of smaller, what we would call a mini treb. So when you add the mini treb participants to the kind of full size trebuchets, we have about 200 students participating.
Now, when it comes to scoring, right, we want to get the projectile into the castle. That's the basic goal, right? Or can you get some points for hitting the castle on the outside wall?
You do the highest points. It's a 50-point project for most students, and obviously we know that the goal of a siege weapon like this is to take down the castle walls. And so, if this was the 14th century Europe, you would be aiming for the walls. We're aiming for the center of the castle. And I happen to be standing on the castle wall on a 24-inch platform. And I like to heckle, think Monty Python and the Holy Grail. I like to stand on the castle wall and I fancy myself the French knights on the top of the high wall, telling my students that their mothers smell of elderberry, if I've quoted that properly.
I believe you have, sir. Yes.
Okay, thank you. And they get some bonus points for hitting me. They get the highest points for getting it in the castle. But we have a series of concentric circles around the castle at 10 and 20 meters from the firing line, from the kind of circumference of the largest circle. And they get, incrementally increasing points for as closer and closer to the castle that they get. And hitting the exterior wall gets them, that's a certain threshold, but inside the castle is the highest possible kind of set of points for students. So, there's a performance score, and then after the event itself, there is an analysis that the students do with only the distance and time measurements. They do some kind of X and Y velocity evaluation. They kind of work backwards from only the distance and time. They can figure out maximum height and a few other parameters of the trajectory. So primarily, that's the kind of post physics that they're doing after the pre physics that they do when they design the trebuchet itself.
What is the most surprising takeaway that you've observed in your students from this event? Because obviously there's the physics to be learned and executed upon, but and I should point out that costuming and decorating the trebuchets is sort of a part of the deal, right?
Absolutely.
And and I'm surprised at how much mental energy has gone into this from my side, watching my son participate. But what if you had to step back and say, I didn't expect this benefit from this event? What would that be?
So, another kind of way of asking that question that I typically ask, maybe as frequently as once a year, is why are we doing this? And the answer is usually surprising, I think, to most people, because we could get a trajectory by going out onto the field and throwing a tennis ball and measure distance and time, and it would be a whole lot easier to kind of do that. And answer to your question is primarily students learn that getting something to work on time and on budget requires enormously more attention than I think they had originally anticipated. A lot of these students, and as adults, we do this too, right? We have an email we have to send, and it's got to be out by Monday at 8 a.m. And we know that we can sit down at Sunday night and put something together. And even if it's managing a fair amount of data in a spreadsheet, we can put that together. But getting something to work involves uncovering some unknowns, right? The surprises in your design that you failed to identify and plan for. And there's a certain beauty, and I don't say this in any sort of mean-spirited way. There's a certain beauty to watching the smartest kids in the school set up the trebuchet and it fires backwards the first time. And there's kind of a moment of, looking at each other like, this doesn't happen to us. We're the smart ones. And this isn't supposed to happen. So it challenges people who are developing, and they're in this kind of very impressionable stage during high school, 16, 17, 18 years old. And they learn that getting something to work is a different animal altogether than talking about it, drawing it on paper, or writing an essay.
That is awesome. You're talking to an audience right now that are all nodding their heads up and down so much they're going to have to go see their chiropractor, because that's really getting something to work. Holy cow, that you encapsulated it. And working with these kids, we're looking at what they're doing stuff. And I said, and I point and I say, why is that done that way? And then I shut up and you watch, and slowly the light bulb kind of dims and gets a little brighter. And then finally they go, oh. So I have to tell you a funny story, Pat. I was doing one of those things with Jared this week on the Trebuchet project. And I was saying, look, this is metal and this is plastic, and there's a very low coefficient of friction between those materials. So it's good as a bearing. And then, you say coefficient of friction and they're like, look at you. And I said, what is coefficient of friction? So we go through this whole thing. I've got a block on a block and I push it. I've got wet ice on wet ice. And this is a unitless measure. It doesn't matter how heavy it is. And they finally get it. And okay, so everybody's heads hit the pillow. He goes to class the next day. He goes into physics. And what are the first words out of your mouth? Coefficient of friction.
I know. I knew we did it as soon as you started the story. I was like, "We're doing that right now."
And he thought it was a setup. Jared says he came home. He says, "You set me up." I'm like, "I didn't set you up."
Yeah.
So that's awesome. Getting something to work. You know what? That's the whole thing. And I know I've thanked you before, but I'm going to thank you again for doing this whole project. It takes a tremendous amount of work to put this together, and you've done an awesome job, and it's so much fun, and the kids learn so much about the real physics.
I really appreciate you acknowledging it. The thing is, you're somebody who sits down and makes things for a living, and you also make things for fun. That's just kind of who you are, and I think some of your listeners are like that. We all know that not everybody is wired that way, and their life experience isn't that way. For a lot of students and their families, even, this is a big undertaking. And it's not that they're kicking and screaming when they come along, but there is some resistance. And I just think everyone, your listeners, and I think you, Spencer, will appreciate from if you were to peer into this whole kind of project, you would see all of the warts and the imperfections and the design flaws that happen so frequently with inexperienced makers. And there's something beautiful about watching that happen when somebody designs something a certain way and it fails. You say to yourself, that's a lesson that kid will never forget. They will now know, and one of the ones that happens a lot is a bit of a creep failure on the main axle. They have these huge spans. There's a huge dynamic event, right? The counterweight drops and it yanks down on the axle. And when you do that 5-10 times, you don't notice much. But after your 50th launch, you're starting to get a bow, kind of a curvature to the arm, and then it introduces some friction, typically on the throwing axle and in the trebuchet arm, and the kids are frustrated sometimes, and I just think to myself, as educators, we want our kids to come in for the win every single time, and part of the challenge in a project like this is creating the muddy imperfect environment where failure happens. And some people interpret that experience as I don't want to say negatively, but not fully positive, right? We weren't fully successful, and it's hard, I think, for people who are on the early part of the trajectory of learning how things get made. They're learning some incredibly valuable lessons, but they don't see that for what it is. The failure of when the trebuchet arm snaps, there was a group that sent me a video this week that showed the end of the arm where the counterweight was. When it dropped down, they didn't leave enough. They probably left a quarter of inch of 2x4
Yep.
material before the hole, and it just ripped the hole out. And I thought, I'm thinking to myself, that's a 60-pound counterweight that's also falling and accelerating up. There's probably hundreds of pounds of force on that tiny little quarter inch of wood, and it's split open and let go. And what a great lesson that is, right? Not only in kind of understanding structures and structural loads, but probably even more importantly of testing beforehand and finding weak points and flaws. And that's something that is a bit difficult to teach in school, that you kind of just have to learn through experience.
Well, it's awesome. And the fact that they're able to get this in high school, because usually I think the hands-on stuff, you don't get to it until you're in a college lab or a college, even internship. And the fact that they're getting it in high school, I think is just fantastic. Well, thank you for coming and sharing your point of view. I think it's important for my audience to figure out what the heck I've been talking about with this stuff made out of dead trees, Well,
thanks for having me. It's always fun to chat with you.
All right, take care, and you're welcome to hang out in the Discord with the other guys, and we'll talk to you really soon. We'll talk to you really soon.
Okay.
All right, take care,
guys.
Bye. Okay, that was awesome. That was Pat Kaplow of Windham High School explaining, Treb Day and Treb Week. Also, the guys in the Discord server. You might want to check on the YouTube stream. I think we have a YouTube stream problem today, so streaming live for reasons that I cannot explain are not working well, and I apologize. It's not me, it's them. Anyway, moving on. So we had a good week of problem solving this week. Not only professionally, because we have some problems to solve there too, but I got a message from a good friend of ours, Mr. John Saunders, and he was working on his new Okamoto. And John was getting some bad surface finishes. So he had just mounted up a new wheel and was trying to get it working. And he and I had been talking about balancing. Thank you, CJ. And he sent me some pictures. Oh, before I do that, Casey is reporting 34 Fahrenheit, 64% relative humidity in Yakima, Washington. Welcome aboard, sir. I think that's your first weather report. Might have been your first weather report. Also, I want to recognize that Dan Gilbert is here down at an Institute of Higher Learning. He's one of the ones that is experiencing the technical challenges of YouTube today. I'm sorry. Anyway, let me show you some pictures of what John sent me. And maybe, let's see, is this the right button? It is the right button. So here is a picture that John sent. Now, this is a part that he's making at Saunders Machine Works for, I guess, I think it's part of his new work holding system. But when you look at the bottom of this workpiece, what do you see? What do you see in this picture? If anybody want to just throw me a suggestion as to what you would interpret this as? Evil says wheel hop. Excellent. Anybody else want to agree, disagree? So this was the first guess. Now the problem is skipping Yeah. Flat lapper, is something's going on. Unix Carbide says trance music, also possible. So as we look at this surface, and Robin is here. I hope he's getting a decent stream. We talked about this. Layer lines. Casey says layer lines. I think he's right. In the end, everything's 3D printed. Am I right? So this was quite interesting. So I started asking questions, and I said to John, tell me what you've done. And he said that he had mounted this new wheel and he had balanced it. And everything seemed fine. And then he went ahead and he did his grind. And the picture I'm showing you now on the screen is the first picture he took. This is before applying PFG Stones. I bet you didn't think I was going to get there. First glance, it looks pretty good. Then he applied the PFG Stones and he sees this. And for those of you on the podcast that can't see these pictures, basically it's a bunch of lines straight across the whole part that looks kind of like wheel hop. Now, wheel hop, when we throw those words out, we think about an imbalance in the wheel, okay, that's causing the wheel to bounce up and down as it spins. John had just gotten a new wheel balancer, an Okamoto wheel balancer, and he was properly. We did a little video FaceTime thing. He was properly balancing his wheel, so his wheel was balanced, yet he was getting these lines. So then I said, "Well, how did you dress your wheel?" So we talked about wheel dress, and he had a single point diamond, and he was dressing. Evils makes a interesting synchronization between the speed of the wheel and the speed of the traverse, ? Very good question. So he dressed the wheel. It sounded like his dress rate was a little fast, which actually does show up later in our analysis, but otherwise it sounded pretty good. And we went back and forth a few times, and I couldn't come up with the answer. So I said, "Is it okay, John? Is it okay if I call Robin and share this stuff with him?" He said, "Absolutely." So I called Robin Renzetti, and we kind of brainstormed a little bit. Same thing. Robin asked questions, diagnosing. And finally, Robin, I don't know if Robin said it explicitly or if he kind of triggered the thought between us, but he basically said, "Did he dress enough?" And I'm like, "Oh, that's a good question," because you could dress a wheel and balance a wheel, and if you did not dress enough, you could have I'm going to use this term, it's not exactly correct, but you could have a flat spot on the wheel. The spacing, this is a very good question from Evils. The spacing of the lines is not the step over. That's what I thought when I first glanced at it. The wheel is traversing perpendicular to those lines. So it really does look like wheel hop. But how could it be wheel hop if across the entire pass of the part, they all lined up? If it was wheel hop, you'd assume that the phase of the wheel when it hits the part during grinding is not going to line up. But they all line up. So it doesn't make any sense. So one of the questions I asked John before I talked to Robin was, "Is your table hydraulic?" And the answer to that question is yes. His table was a hydraulic table. So there wasn't any accidental synchronization of the table and the wheel. Anyway, Robin says, "I don't think he dressed enough." And I realized that could lead to a spot on the wheel which was never properly dressed, i.e. a flat spot. So the lines you're seeing, if that's true, the lines you're seeing are not going down. Those lines are going up. So I did one of the pictures that John sent me. I don't know if I can show it. Let's see. I asked him for a really close shot. Yeah, I can't quite see it, but I asked for a really close shot, and then I blew it up on my screen, and I was actually able to see some grain structure in each of those lines. Well, to make a long story short, I believe I saw evidence of his fast dress because there were these little scratch marks that were spaced perfectly, and it came from the overly fast dress. Now, we have a saying, I have a saying in engineering, which is, it's never one problem, it's always two problems. So two things happened here. Number one, his fast dress was too fast, but that gave us a little evidence, and the wheel hop idea and the underdressing gave us a little evidence, and that led to the epiphany. And here is the epiphany. When you dress the wheel, do you close the loop? In other words, do you ask the question, did the wheel get dressed? And I have to be as guilty as the next guy, as a lot of times you don't. Evil says, so not the entire circumference is dressed. Right. So Robin said, sometimes when you mount that new wheel, you've got to dress off 10, 15 thousandths of an inch. And that was dead on. So I said, well, you can mark the wheel with a pencil. Don't use a Sharpie. Mark the wheel with a pencil, because basically the graphite's not going to hurt anything. And then you dress, and you should be able to dress off all of your pencil marks. Well, John did not mark it with a pencil and did not have a way to observe that, and did not have a handy carpenter's pencil, which has enough lead to do the job. So that's sort of the next step. His pencils are on order. I found a couple of items on Amazon, which I have not yet added to the links page. One was a relatively inexpensive carpenter's pencil, which looked pretty good. But then we found artists use these charcoal sticks to do charcoal paintings. And I ordered some of these charcoal sticks as a candidate for doing exactly what we're talking about, because I think it'll be more efficient. So the idea is you mark the wheel, you dress the wheel, and you observe the marking. Now, an old grinder hand is not going to do that, because the wheel is going to look different when it's dressed than when it's not dressed, and you might be able to see the difference. And a very experienced old master grind hand is going to say, why don't you put your finger on the wheel? Now, kids, don't do this at home. But Robin said, if you put your finger on the wheel, A, you'll be very surprised because it doesn't feel like anything. And B, you should be able to feel a little jumping or a little vibration if there in fact is a flat spot. And what I said to Robin is these words. I said, there is no way I'm telling John to put his finger on the grinding wheel. So, but the thought is there, and it's valid. And this was the takeaway that I came off with, which was close the loop. Once you dress the wheel, observe that you in fact dress the wheel. Now, you may recall in previous videos I showed mounting up the diamond wheel and getting it trued and dressed, and we put an indicator on the wheel to observe that it was in fact true. That would have picked up a flat spot, but I don't expect that anybody's going to want to run an indicator on a wheel every time they dress it, because that happens too often. So this is the trick, and it's especially important in a new wheel, right? You're just mounted a wheel. What do? I think it's very important to make sure you get a very complete dress on the wheel. And what seems obvious now did not seem obvious at the beginning of this conversation. So, hey, K-Bonk is here. He's checking in with a spinning vortex from 19123 Philadelphia. Yeah, K-Bonk, we know that there's weird stuff going on YouTube, so if you're getting a little glitchy, we understand. So that was the story of the grinding puzzle this week, and John switched to a white wheel that he had from this wheel, and he started getting magnificent results, indicating that his process is good. And the other thing that comes out of this whole conversation is the use of PFG stones. So the PFG stones were able to show the defect, and before using the PFG stones, it looked good. You looked at the parts, it looks fine. And as soon as he hit it with PFG stones, he was able to detect the issue. So if you don't have a set of PFG stones, go to pfgstones.com. Okay, so that's our that was the puzzle of the week, the puzzle du jour, which of course doesn't mean puzzle of the week. Let's see. DBX says Pico makes a good pencil. He uses it on his sharpening stones. Excellent. And he put the link into the chat on Discord. There you have it. So I know I will now more frequently mark my wheels when I'm first setting them up. Rob Wren says, applies mainly to the first mounting of a wheel. Once you have it fully dressed, it is not an issue. Absolutely, totally agree. So there you go, folks. So if you have any takeaways from this, that's it. Is that when on that first mounting of the wheel, to ensure a complete dress, use a pencil. Don't use a pen. Don't use a pen. And don't use a Sharpie. Yeah. Okay, so that was the story. So you guys getting YouTube again more smoothly now? Have things straightened out? Because it looks okay on my end. Unix Carbide asks, for the uninitiated, why not a Sharpie? Maybe a dumb question. It's not a dumb question. The only reason for not a Sharpie, well, there's two reasons for not a Sharpie. The most important one is that the ink will seep into the stone deeper than you want. And now you can dress it off and you still see the Sharpie, and you'll keep going. You will get a complete dress, but you'll be chasing that ink that's soaked into a stone that has any sort of open structure. That's the problem. Rob Renz says, everybody get your pencils out. That's a little pun there. He says, get a pica pencil, about 3 millimeter diameter lead in a mechanical pencil. Oh, neat. Oh, so pica pencil lead in a mechanical pencil, 3 millimeter diameter. That's what he's recommending. And I will report on these artist sticks. They may be good. They may be terrible for the application. I will let you know. That is my homework for next week. So I hope I added something to your toolbox, because I think that was a good one. And also by next week, we should have a report back from John Saunders as to how the new approach worked and if he's back in business. But he's working with a white wheel and everything's great. Unix says charcoal is great. I'd worry that it doesn't all spin right off. Well, we'll find out. It was an idea I had while I was searching for carpenter's pencils, and hopefully it'll work out. Let's see. Oh, I never gave you the report from Manchester Airport, as is tradition. Manchester Airport currently is winds 320 at 7 knots, visibility 10 miles. Overcast 2200, temperature 9, dew point 4, altimeter 3017. Remarks. Here's a new symbol for you guys. Rain ending 26 minutes after the hour. So about 13 minutes ago, the rain ended. And there you go. So I want to show you another picture. Let's see if I could find it. My good friend who is with us in the chat, Unix Carbide, also known as Ike, said, hey, I got this project, and we could talk about the project a little bit. Actually, hey, Ike, you want to come in live? Turn on your camera, come in live. We'll talk a little bit about what you're doing, and I'll show this picture, and we could explain it. There he is. No, he isn't. Try it again. Okay. So joining us from Williamsburg, Brooklyn, New York, as soon as I find the right button, is Unix Carbide. Hello.
Hi, am I muted? Should I be?
I hear you. Can you hear me?
Yeah. Hi.
So before I show the solution, let's show the problem.
Yeah. Let me grab the pieces. Will you explain it?
Okay. So Unix is building 3D printers, and he's built a really nice. Hey, thanks, Rob Renz, for the report on the YouTube stream. Unix built a 3D printer, and he's building other 3D printers, and he's using these linear rails. Not any old linear rails, but really cheap linear rails.
Really cheap.
So, go ahead.
I have in hand, I cannot get to the rails. You really did catch me halfway through. Sorry, I wasn't prepared for this, man.
No, we this was unplanned.
Okay.
Let me set it up. So you have these rails, right? You buy them for how much? What was the cost of those rails?
Oh, the good stuff's $12 a piece on the cheap end.
And how long are they?
300 millimeters to maybe 400 or 500 millimeters down to 100 millimeters.
Okay, so I know you guys can't see the chat in this view, but Rob Renz, how much would a 300 millimeter long linear rail that you would allow in your shop cost? That's the question. You have to be willing to allow it in the Renzetti shop. What would a 300 millimeter? What size roughly? Half inch? Was it 20 millimeter wide? Ike?
Oh, they're the common sizes: MGN 9, MGN 12, MGN 15. So that's 9 millimeters, 12 millimeters, 15 millimeters, respectively. Okay. And they have a preloaded tension on roller bearing cages. Mm-hmm. So a number of ball bearings ride along grooves in the side of the rail. Mm-hmm. And then they run through a little raceway on the outside part of the bearing. And then the cheap ones come from the expensive ones. Really, the industry is built on. 3D printers and most of what gets built is built on industrial offcuts, and that's what makes it so cheap and makes them so, just kind of the lingua franca of 3D printing. And make a lot as possible. I have personally measured on a 300 millimeter rail that cost $12. I have measured it for parallelism and flatness on a surface plate, and come out, at the other end, maybe 5 to 8 microns and micrometers end to end, like very, very good. These were great rails. But that same great rail was obviously put into a chop saw in a back alley somewhere before it was sent to me to make it 300 millimeters long. So that's the trade-off here. But even the very good rails that people buy from various companies, I'm assuming being one of the primary high-end distributors for the stuff, those could be about $400 for a 300 millimeter rail, straight from the factory, and I'm sure they come from a clean room and from a good place.
Yeah,
they're delightful. Those rails,
they're not cut on a chop saw in a back alley.
They're not cut on a chop saw in a back alley. That's what you're paying for, at least.
Okay.
However, those rails, if you so much go to use them and perhaps ding them into something while you're working, can accrue the same defects that you get from somebody throwing a chop saw in the back alley. It's less likely, but Every precision thing can become imprecise, right?
We have this just in. We have some data to share. So
yes.
Rob Renz reports a linear rail that he would allow in his shop in that size range, $450.
Yeah. Yeah.
And you paid
12.
$12. Okay. I just want to frame that just so everybody understands what we're talking about.
Yeah. Yeah.
So what was the problem we had to solve?
Well, let me actually throw this one thing out just on that comparison end. When then making a 3D print using a printer, the relative effect of the $400 rail versus the $12 rail, the effect on your final print outcome is going to be, well, you got other problems. You're 3D printing. You've got a lot of other problems. So
it'd be less than the temperature control that you don't have.
Correct. Exactly. So this is where these rails are really, in my mind, that's one of the that's why they're so popular.
So Evils asks, once you clean the abrasive dust off of them, they're good rails for the price? ?
Yes.
Smirky face.
Yes.
And
I mean, that's the other thing. There's cleaning them and disassembling the rail, cleaning it and re-greasing it properly is part of the work involved.
And DBX reminds us that he played guitar in chop saw in a back alley back in the 70s.
I remember them.
Yeah, they were good. A little screechy.
Yeah.
So what did we do? What did you do? And then what did we do?
Okay, so what I did was I had a set of rails on my printer that had obviously been clamped in a chop saw, and they were producing artifacts at a specific height in my prints because that clamping had left a defect on the actual print rails. And what I originally did, I have these fine things, these PFG Stones, beveled set, which I have always wanted my whole life, and I've got them now.
I've heard about these. They're very good.
They're very good. And I thought, I'm going to void the warranty. Why not? And I took the very thin beveled edge part, and I ran it inside of the curved part of the rail, ran it the length as though I was doing a rounded part, and just gently moved my hand along. And yes, I could feel exactly where that clamp had been, and I could feel other defects in there disappear, doing the PFG flattened thing.
The unapproved PFG.
Totally unapproved. Voided the warranty. And voila! I put the rails on the printer, cleaned everything up, and I was able to produce charts and graphs for resonance measurements with an accelerometer that were even and consistent and fantastic, in fact. And the print artifact disappeared. I was delighted as all get out. And I started sharing this with other fellow 3D printer builder folks, and look at these stones. Okay, let me explain this. They're like, oh, cool. I'll just get my whetstone that I sharpen the kitchen knife with. No. That will remove material. You don't want that. And then showed them the stones, and they said, the stones cost as much as my printer. And I was like, yeah, well, I mean, that's what it takes to produce it.
That's only because they are not using Renzetti approved $450 linear rails.
Well, see, this is the thing. Even those rails, some of the real honest and hardcore folks that I talk to who have built with very expensive rails will also attest to, imperfections. We're using these machines, of course. Things happen. Like, oops, there was that time and it exploded and it hit the side. And
so the important part was the roundy part of the rail where the balls run, right?
Yep. That groove needs to be straight and parallel. And that is that. It needs to be straight, and the two of them need to be parallel.
So you and I got to talking.
Yep.
And we said, hey, why not run a pin down there? And
that was your idea. Yeah. I'm going to credit you for that for eternity, whether you like it or not. It's a great idea. Why not run special idea is why not use the stone? Why not run a hardened pin that is itself flat and true down that groove that is the exact same size as the ball bearing? And how about this? Gauge pins are fairly inexpensive for the job. And look at that. How hard are they? So I went and took my Rockwell files, which is a home person's way of measuring hardness of a metal thing. Is that a fair way of putting it?
It's an inexpensive, quick and dirty measure of hardness.
Yeah, gets you in the ballpark of hardness. And we found what was the Rockwell? I forgot. It's in somewhere in Discord in here.
Oh well,
They're not that hard. 45.
I think we did. No, it was like 32 or something. Or
yeah,
it was in the neighborhood. I just remember thinking it was in the neighborhood of a pre-hard material, like which would be like 35 to 40.
Yep. And the two common variants of the material are the hardened steel and stainless, which should be similar.
So stainless will be softer. Yeah, stainless will be softer.
Sure. So so that's one thing. And then what is it? A pin, common gauge pin is in the neighborhood, what, 65? 68? A lot of them say 68. Exactly. Yeah, sure. Okay.
60 to 65, yeah.
Yep. So if you run this, if you get the right diameter of the ball, took out the ball, did some measures with the micrometer, and took balls out and measured a couple of them, got the diameter. And the thing about the pins is that, am I going to get the exact same size that I need? Probably not. Oh, I'll just get a couple in the range, right?
Yep.
So measuring down to 1 micrometer of getting a couple of different pins to spread across. Spencer's idea was to grind it with a dead flat using a grinder. My thought is I'd like to try a comparison with a hand jig that somebody could 3D print, trying to make something accessible for other 3D print builders. But the real hard part here is that's all still work. So doing it with a grinder is kind of that's kind of cool. Because making those dead flats. And then there's a handle. This is the old one, which I promised to my daughter, and I'm cleaning my table so I can't find the better one. Made a holder, which is which way am I going on this? Which is basically just a way to hold the pin. This is a V groove. This one was way too short. The final design is much longer. On the back, there is a very hard stopper to stop the pin. The only thing you really need to be where you're going to have pressure is here, and then also down. So to hold the pin and get it inside the groove, I found that a dab of rubber cement on here will very, very nicely hold the pin in place with plenty of downward, like all the downward pressure you want to apply, and allow you to remove it quickly and put another one in.
So for our podcast listeners, Rob Wren says only run a pin if the races are not Gothic arch profile. So I think what Robin is saying is there is not necessarily a circle, a perfectly circular profile. So for the podcast listeners, what we're talking about is taking a pin in a groove and pushing the pin like you were pushing the end of a log, right, down a trail, and using it as effectively as almost like a plane, or it's like a knife, right? So we want the front edge of that thing to be dead flat, dead sharp, and it's going to make the profile of the pin. And because the pin is long and you're pushing the whole pin down, if the groove is the profile of the pin, basically nothing happens. But if there's a defect that's protruding from that perfect profile, then it's going to hit it and cut it because the pin is much harder than the rail. And that was the idea that we were going for. And what were your results?
Well, I haven't completed one yet to actually run it down a rail.
Okay.
Yeah, I have some rails that are awful that I can use it on, but I have not completed sharpening one of the pins on my side.
Now, Unix, you put into GitHub a repo. Listen, people, listen to the words coming out. The new words I have. I note that you committed to a repo, which is public on GitHub, called Coney Island Snowplow, with an underscore between Coney Island and Snowplow. Coney Island Snowplow, which, by the way, I appreciate the fact that you named it that, because that's my old neighborhood.
Yeah, that's what I figured. This was your idea, so give it a nod.
Nice way to say it's all my fault. Of course, now we all have homework to figure out.
If I ruin my rails, I'm gonna be, my lawyer's coming after you for the $12.
For the $12. Okay, yeah. So I'm going to turn on the slide here. There's just one photo that I brought to the party here, and it's up on the screen. I'm going to actually switch to a bigger view of this. Give me a second.
Oh, is that a good?
Okay, your audio is still with us, but you're...
Yay.
Okay, so there's a picture of a little 3D printed plate that I just made real quick. And there's a pin that you ordered from Vermont Gage. You actually got it from Travers Tools, I think.
Travers Tools, yeah. They had the best price and a bunch of metric, very clearly organized pins.
So this is a little 3D printed plate with some V grooves that don't go all the way across the plate. They stop to provide a little a location for the pin, and this plate will go up against my grinder vise, and then we will tighten the vise on up to 4 pins, and then I can go in with the grinder and kiss the ends of the pins and make them dead flat. And that's what you're seeing on the screen. Now, you might ask, but wait, what if you're doing pins that are of differing sizes? And the answer is, in a perfect world, you'd be right. I have to have a different size groove. Otherwise, they're not going to clamp when I close the vise if they're different sizes. Well, I thought of that, bucko. The fact that it's 3D printed and it's made out of plastic means it's going to have a little goosh factor. Yeah. And the goosh factor means I will be able to tighten that vise. The plastic will give a little bit, but because we have such a long capture of the pin, the chances of it tilting is very, very small, but the chances of squishing just enough so that it can be held is excellent. So that was my first design, as denoted by my nomenclature P1. And I will be taking these pins and giving you your dead flat, knife-like, magnificent ends for testing. What do you think of that?
Then I will run them down the rails and we'll see if I don't ruin a few.
Yeah,
I'll see how it goes. Yeah.
$12 bucks.
That's the other fun part of $12 is you can do this. And
yeah. Evils asks a good question. He says, isn't there a risk of the pin's edge grabbing and digging in? Allow me to address this, Your Honor. Because the force of the holder, your magnificent sled that we called it, is really behind the pin, and the pin is long, the probability that edge is going to have enough flex at the end to actually dig is low. Plus, the end is going to be zero rake. It's not going to be like sharp like a chisel. So if you're running a chisel down and you hit something, the chisel might want to dig in. But this
I want to note that, yeah.
Yeah, the rake angle here is zero, no rake angle. And the rest of the argument will be addressed after we try it. Thank you very much.
Yeah, and I think there's one thing I've thought about with regard to that. If people, I'll have to provide this once I try it. If people were to say not remove the bearing cage and then put it down on a table or flat surface and try this, yeah, it's probably going to bend and you'll probably do something bad. So taking off the bearing cage, which a lot of people in 3D printing regard as like a magic procedure because it's hard, it's annoying. The balls want to jump out and you've got grease in your hands. Taking off the bearing cage is kind of just requisite. And I'm going to do it on top of a surface plate just for nerdery. But it really shouldn't move too much on top of a lot of relatively flat surfaces. We'll see.
So Rob Renz points out, Rob Renz says, if the race is not Gothic arch, then the diameter will probably be 104% of the ball diameter, not the diameter of the ball. So I guess it's important to observe the groove to figure out what you need rather than observe the ball to figure out what you need.
Bingo. So that was one reason, Spencer, you got shipped a few pins, and I ordered a big, mine still took forever to come because I ordered a big spread of pins that I could abuse like this.
Yeah.
And the my thought is, putting the pin in the groove is going to be the most important measure you could take, more than the ball. Because also measuring a little ball bearing that's 1.5 millimeters in, I mean, come on, is that really going to be easy? Is that going to give us a good measure for what's really going on?
I think your idea of having a bunch of gauge pins, I mean, not like anybody ever measured things with gauge pins before, but having a series of them and then feeling it and saying, yeah, that's about, no wiggle, wiggle, next pin, wiggle, next pin, no wiggle. It's like, I think I found the diameter of the, So anyway, this is what we call engineering, people. We're supposed to fail.
One other terrible thought I have, which might make it more laborious to use, is that it might actually take several pins in gradated sizes to actually get a good raceway. Like, actually, I don't know. I'm going to try it and try this all and see. But you may want to start with a large one, run a few passes, then do a smaller and smaller because you're working your way up those walls.
We have two good suggestions from the Peanut Gallery. Casey says, would lapping compound work? And that actually was one of the original ideas, is to use a pin for, to lap it. So that, I think the answer is kind of. The problem with lapping compound, and Rob Renz, you could back me up on this, is that the softer material is going to want to embed the lapping compound. And that's the other way. We're the wrong way around. Rob Renz says, I suggest using the pin to burnish, not to cut. So Rob Renz is saying no cutting, just burnishing. So that means you'd want that end to actually be rounded or be beveled and let it do burnishing. So burnishing is a fancy way of saying is lapping without the lapping compound, right? So these are awesome ideas.
Is somebody on here capable of putting a perfect round on the end of the pin using a lathe? I mean, if anybody can pull that off, we need lots of them cheap.
Well, actually, we could take the exact same setup, and I can go over and just push some buttons and on a white wheel and do a form on a wheel, and then run them across your. That wouldn't give you a round, a spherical. But we could set up the. I see
what you're saying. Yep.
If we set up the spin jig, we could put we're not going to do any of this. Just go try it, and let's see what happens.
Not a sharp. Evil says for burnishing, you don't need a round. You just need not a sharp angle. All right, that sounds fair enough.
Well, I want the ultimate not a sharp angle.
Well, I think one other objective though here is cheap and easy to produce. The idea here, because if this is all good, hey, I already got this. I have my PFG Stones with the bevel. That worked really, really well. Like, I don't need more technology here. This is more of a trying to do something that's more useful to more people kind of a thing.
Rob Renz says, I did a video on measuring balls. Thank you, Rob Renz. We will look that up. Do you remember about when, or maybe if you we'll have to look at your library. So go to Rob Renz.
Watch that for sure. That's cool.
Rob Renz on YouTube. Okay, I'm glad that wasn't on the video. Yeah. I will not be repeating that. Thank you very much, Evils. Okay, you know what? We did it. I think we properly described the problem. We described a solution that we're kind of trying out. I love your design of your sled. Please give a little more about the industrial design, because it's pretty cool.
Oh, I thought I need somewhere to keep the pins because everything's, needs a home. And so I found a threaded thing on Thingiverse that I ended up having to redraw from scratch. But it takes a bottle cap from a soda bottle. And I thought, oh, that's great. One less thing to print. I'm trying to do this really fast and really dirty and nice, and ta-da, boom, you get a tool. I was thinking of like a Noga, what is it? Where's my brain today?
You mean the deburring tool.
Deburring tool. Thank you.
With the bits and the
tool that has the handle. You put your bits in. Cute.
By the way, Evil says it's Robin's gauge ball video.
Okay.
So we'll have to look on that for that. Anyway, we will thank you for coming on and telling about this. We will continue to report. This is a cool project. Happy to support. And I will get back to you as soon as I'm able to take my PFG Stone wheel off the grinder. I have customers telling me I'm not allowed to do that yet. So as soon as I can free up the grinder for actual grinding of other projects, I will let you know. Thanks for being here, buddy.
Well, if this works out, I'll be hawking my beveled PFG Stones somewhere. Because what am I gonna?
Just take them down to Canal Street.
Yeah, I'll take them down to Canal Street, sit there on a blanket and
sell them on Canal Street. Everybody on Canal Street. Oh, we got a link. Rob Ren's. Oh, there it is. Okay, two things are happening at once. DBX has posted. Let me switch over to the other scene here, just so I could show the thing. So DBX has posted the link in the Discord chat, but it's called Making Precision Gauge Balls by Rob Renz on YouTube. And Rob Renz just said, I have a lot to add if you want me on. So you're not yet on Discord. Yeah, Robin, you're not yet on Discord, and I'm not set up to do a non-Discord thing yet today. So I'll tell you what.
Helicopter a team over to his house with a laptop.
That might be easier. No, because last time we had Robin on via Zoom, which he's set up for. But I am today I'm not set up for that. So do you want to come on next week and we'll do the follow-up to this, Robin? And if the answer is yes, we'll set you up. We'll take care of you. I'm trying to get Robin on Discord just because all the cool kids are doing it. Okay, so I'm going to say thank you to everyone. We're going over a little bit, and I don't want to overstay my welcome. Thanks again, Ike. We'll pick this up next week. Will you be around next week?
I hope so. I think so. Yes.
Okay, good.
Now I guess I have to be, right?
Yeah, pretty much.
Yeah, cool.
You're stuck. All right. Thanks, Ike. Robin, thank you. Let's see if we could pull you in next weekend. And if there's a problem with that, let me know. And we'll go from there. WR Rocket, I saw you show up. He said, anneal the pins and then lap with them. That's sort of going around the wrong way, but it could happen. Okay. Yeah, Rob Wren says, pins don't need rounded ends to burnish. Just support only in the center and let it flex. I didn't think it had an ego, but we'll let it flex. Hey, thanks for being here. This has been PFG Live, and we've done it again. You never know where this thing's going to lead, so you have to show up every week. For those of you that had the glitchies on YouTube, I don't know what happened, but this will be up for your viewing pleasure afterwards. Evils correctly points out to Rob Renz, his own words, everything is rubber. Let it work to your advantage. Well put. Okay, from Windham, New Hampshire, this has been PFG Live. We'll see you guys next week for more exciting stuff. Take care.